This morning we're going to be talking a little bit about science, what it is, what's the purpose of science. Now, I think you all understand that in science we try to find the truth, whatever that is. Nature will reveal itself to us if we study it and observe carefully. We usually use the scientific method. We'll talk about that on a different day. But for right now, let's talk a little bit about science. So let me get this started here. It's fine. So when you think of science, you might think of things like beakers and in the laboratory and so on, and that's fine. Now, there are different things about science. There is basic research. Let me make this a little bit smaller here. There's basic research, and that is what's done at universities, trying to uncover how things actually work. It doesn't actually have to serve a purpose, a useful purpose. So basic research tells us, leads us to greater understanding of how the natural world operates. Once we understand that, then we can apply that information. The application of that basic research is what you would refer to as technology or applied science. So applied science, applied research aims to develop something useful from the knowledge that we gain. So we might understand that the metal aluminum is a very lightweight yet very strong metal. So it would make a lot of sense to make a spaceship out of aluminum versus steel. It would be just prohibitively heavy to try to launch a steel rocket into space. The functions of science, let's just make sure we understand the difference of pure science and applied science. Pure science, you simply are trying to find out information, searching for facts, trying to understand things. Applied science, though, is using that knowledge in some practical way. Most of us enjoy the benefits of technology. We enjoy our cell phones and like when I grew up, I was born in 1966, so I would watch a show like Star Trek, and they would actually pull out something that looked like this, and they would open it up, and they would be talking to the ship, and there were no wires attached to that. Now, I thought that was incredible, right? Nowadays, you and I would say, well, that's a very old cell phone you have in your hand. Well, that's true, and I have even an older cell phone here, right? It doesn't even fold out. And then, of course, before that, you would have had to use a phone like this, and you would have had to dial the number and so on and make your phone call, right? And nowadays, most of you have something that looks a little bit more like this. It's got cameras on it. You can drop them, you can get them wet, and it's pretty cool technology, right? We've come a long way. Just in your lifetime, think about how fast computers have gotten and how much more memory they've gotten, right? If you have a computer that's 10 years old, it's almost useless. It's so slow in what it can do. And the new ones now all have touch screens, and you can write on them with a stylus and an incredible resolution, 4K or higher resolution. So technology is something that we like. Now, one of the problems with technology is it can cost a lot of money because you have to pay for all the basic research that developed that technology. Now, in science, we like to establish a cause and effect relationship. So it's pretty clear that if you smoke, that is a contributing factor to developing cancer. If you go outside a lot, you have fair skin, and you don't wear sunscreen, you can develop skin cancer. If you don't study for a class, don't do the homework, and don't pay attention in class, you tend to do very poorly. These are all cause and effect relationships, right? Now, for a long time, the cigarette industry, the scientists in the cigarette industry denied that cigarettes cause cancer. Now, in truth, they weren't lying. You can't prove that anything causes something else, but you look for statistical relationships. There's a strong correlation between the fact that if you smoke, you can develop oral cancer, lung cancer, and other types of problems. I've got a little picture here. We're talking about pure scientists. That's kind of what you think of, I think, the graphic there on the left. And it's showing us here a scientist. Now, what do you notice that's maybe wrong? Now, shame on you if you said there's a woman scientist. Of course there's women scientists, just as there's male scientists and everybody else. How about the fact that she's probably not wearing safety glasses or goggles, right? That's an important thing to do. Well, again, pure science, or just science in general, is looking for facts about the natural world. We look for these cause and effect relationships. It's not generally driven by money. You don't go into science because you say, I want to be a startup, discover something and make millions and billions of dollars, right? Instead, you're a curious individual. You want to understand how the world operates around you. You want to explore and conquer new things. Look, we know less about the ocean, the deep parts of the ocean, than we do the moon, right? So there are still things that if you want to be an explorer, to be the first to do something, you can still do that in science, right? We're trying to find cures for things like Parkinson's disease or MS or cancer or just a myriad of other things that hurt mankind. And so these are new areas open for exploration for people to find answers to. So we've touched on what is applied science. Another name for applied science is technology. It's the practical application of these scientific discoveries. When man went to the moon in 1969, there was communication from the moon to the Earth. There was no telephone line. They didn't shoot a rocket ship up and then have a telephone wire coming from the back end of the spaceship to Earth. Instead, they bounced those signals off satellites, and then they received them here on Earth. That was the beginnings of the development of cell phones. So people that say, why do we do pure science? Why do we go to the moon? Well, we learn a whole bunch of cool things trying to solve problems, the technical problems of achieving such a lofty goal. For instance, maybe you go to McDonald's and you like those little ketchup packets, right? That was all developed from the space race, trying to package food that could be used in space. And nowadays we take it for granted that that's just how you get your ketchup. So technology improves our lives. I put a couple examples here: cell phones, biodegradable garbage bags. Let's talk about biodegradable garbage bags. I think you understand, at least if you live in Bloomington Normal, that we recycle. So you separate out the recyclables from the non-recyclable trash, and that is helpful to the environment. But some towns don't do that. And if you put all your trash in a garbage bag and seal it up in plastic, that garbage bag won't rot for decades, which means that garbage is just sort of sealed in there. So biodegradable garbage bags have a small amount of material that when they get wet dissolve, and the garbage bag breaks apart. Let me give you another example of that. In hospitals, they have to do lots and lots of laundry, and sometimes there's blood, or maybe it's a childbirth, lots of fluids that get contaminated onto the sheets. Now, you're going to put gloves on and grab the sheets and put them in a bag. Then it's going to probably sit for a little while before it's thrown into the washing machine. So what they do is they use biodegradable garbage bags that you can take the entire bag of laundry, throw the entire bag into the washing machine, and as it washes, the bag dissolves, the laundry is cleaned, and nobody has to touch it a second time. So again, I would think that's an improvement over reaching in, touching very dirty, soiled laundry. Well, let's talk about Corning glass and going to the moon. We'll stick with that theme for a bit longer. So, when going to the moon, they needed the NASA required a clear plastic or glass, face shield, something that the astronauts could see through but wouldn't crack from the extreme difference in temperature. You have to remember, the astronaut is probably at about 60 degrees Fahrenheit. inside the spacesuit, and then the outside of the spacesuit is about 4 Kelvin. Well, 4 Kelvin is like minus 400 and some degrees Fahrenheit. That's an extreme difference in temperatures, negative 400 to 60, and most glass would crack. So they offered a huge amount of money for any company that could come up with a material that could withstand those extremes in temperature. Well, it turned out that Corning Glass Company made a product, and maybe you're familiar with Corning Glass. This is a Corning Glass bake dish. They generally have some flower patterns on them, or maybe it looks like these bowls, and they can go directly from the freezer into the oven and they don't break. Now, notice that if I try to look through this, I can't see through it. It's opaque. So in terms of, did Corning Glass get the contract with NASA? No, they didn't. They failed. However, they made millions and probably billions and hundreds of billions of dollars in the last 50 years by simply selling their failed glassware that you and I would just call bakeware or Corning glassware that can withstand those extremes in temperatures. And oftentimes that is how science is done. I would call that serendipity. It's an accident that turned out to be very fortunate for you. So even though they could have got the glass and maybe made $15 million in 1969 and never used that glass for anything else, that's not how it worked out for them. Their failure ended up being a very great success. Other failures would be, some of you maybe use these little sticky notes, right? You write on them and you can stick them on stuff. Well, that was a failure. A gentleman was working in a lab and he had some papers in a beaker, and at the end of the day he was in a hurry to go home, and he accidentally tipped over the beaker with some liquid in it, and it spilled on the paper, and he said, I'm going home, I'll deal with that tomorrow. Well, when he came back the next day, he noticed that the papers could be peeled apart and they were somewhat sticky, and it didn't ruin the paper. So there was nobody that said, ooh, what we really need are sticky notes. Instead, it was an accident, and that's oftentimes how science is discovered, through accidents and careful observation. Let's do another example. This is a rather crude example, I suppose, but fertilizers are an example of technology. Now, the early indigenous people, when the pilgrims came, showed the pilgrims how to grow corn or maize. And they realized that if they put corn in the same field year after year, the corn production decreased and decreased and decreased. So what the Native Americans taught them to do is to use cow dung to add fertilizer back to the soil, and that increased the production. Now, maybe your parents put their own fertilizer down. This is a photograph of my neighbor Bob here putting fertilizer down. We have a little competition where we both try to have a nice green, healthy looking lawn. Okay? Now, these numbers, the 5, 15, and 10, represent the percent nitrogen, phosphorus, and potassium in the bag of fertilizer. Now, each one does something different. So nitrogen, phosphorus, and potassium, those are elements. Nitrogen makes your grass really green. So in the spring, you would use a very high nitrogen number because you want your grass to green up and look nice. And in the fall, you're not interested in the grass growing green and tall because you don't want to cut it anymore. So you would have a lower nitrogen level in the fall. If you put too much nitrogen fertilizer on your plants, maybe you have a vegetable garden, if you put too much on there, you're going to end up having beautiful, tall, 6-foot tall tomato plants that look super healthy, but they have absolutely no fruits on them. And the reason for that, plants need to stress a little bit. They need to suffer. And now, if we can personify them, when they feel they're stressed, they might die, they produce offspring, fruits. And so a little bit of stress to your plants is okay if you want them to flower. That's why if you have an orchid, it'll say only water it once a week. You don't want to water it every day, make its life too cushy. It won't produce flowers. Now, phosphorus gives energy and vitality to the plant, so it's going to produce rapid maturity and flowering. So they sell products called Miracle Grow, and some of them are specifically called Bloom Plus. And it's a very high phosphorus containing material, and it causes the flowers, especially if they're annuals and they're only going to flower for one season, to promote and bloom all season long. And finally, potassium is going to help develop the plant roots in your plants. Now, the plant roots, if they go down deeper and deeper and deeper, that means the plant is going to be more drought tolerant. So it's important to get those roots to go deep down. That's why if you water your lawn, you should water it maybe once a week for an hour. And then what happens is the water goes down farther into the ground, and the roots have to work their way down farther under the ground where it's cooler, and it tends to be healthier. If instead you water your lawn for 10 minutes every single day, the roots stay on the surface and they don't become very drought tolerant. Instead, they wilt as soon as it gets very hot out. So having a basic knowledge of what those chemicals do can be somewhat useful to the average homeowner. All right, what else can we talk about? So if you think about it, if you add fertilizers to your vegetable garden, it's going to produce more food, which is going to feed more people, and that's a positive. That is making people's lives better. I know I have a very large vegetable garden, and it seems like every day or two I'm knocking on my neighbor's doors, bringing over tomatoes and cucumbers and okra and collard greens and peppers and loofah and everything else we grow in our garden, right? And my neighbors appreciate it, and I enjoy sharing the bounty of food that I get with them. All right, well, let's talk a little bit about other things you can do. My garden, it tends to be an organic garden. I don't put a lot of chemicals on it, any chemicals in fact, because I want it to be healthy. Now, some people are concerned about sugar. Now, I know right now nobody's going to parties, or at least you shouldn't be going to parties, but when we finally get post-COVID and you can have a party, sometimes they'll have pop for people to drink, and they might put it in a little kiddie pool with ice and water. And the one thing you'll notice is the diet always floats on top of the water, and the Coca-Cola, anything with sugar, will sink. Now the reason for that has to do with how they are sweetened. Sugar is the form, at least in Coca-Cola, is sucrose. It's a combination of, it's a disaccharide called glucose and fructose, and I think you probably studied that in biology. Here's its formula. It's a very large molecule. Now, saccharin, on the other hand, is, well, it's also a relatively large molecule, but here's the key. Saccharin is an artificial sweetener. It's hundreds of times sweeter than sugar. So you might only need to add 3 grams of it to a can of Diet Coke, where you might have to add 30 grams or 40 grams of sugar to Coca-Cola to have the same sweet flavor in your mouth. Now, some people don't like the taste of saccharin. They can taste it. It's a little bit bitter. Saccharin has other problems. For some women, the way it's processed, it can cause a birth defect. So you probably shouldn't be drinking, Diet Coke when you're pregnant. I mean, just think about it for a second. You're going to be putting on weight in your midsection as you get more pregnant, and you're going to, quote, maybe look fat. I know I shouldn't use that term, but you're going to look bigger. So if you want to drink Coke or with sugar, just go ahead and drink it. Just drink it in moderation. You don't want to add too much weight during that pregnancy. We'll look at the dehydration of sugar. That'll be maybe a demo I can do for you on one of our live remote days, where we can take the sugar, and I'm going to add sulfuric acid, concentrated acid, and it will consume, burn up right in front of your eyes, that sugar, and it'll form carbon, and then it'll give off some gas. And I'll maybe do that for you so you can see that. So that's kind of a fun little thing we can do as well. There's the molecule of sucrose, just kind of drawn using some molecular models. All right. With science, with technology, there's always a pro and a con, a risk benefit. Look, if you want to be using a cell phone and this is your cell phone, this thing's going to cost you like $30 a year to operate. No, there's no internet on it. You can't shoot pictures. But if all you're trying to do is maybe text your friends or call for a ride home, this works just fine. You know, if I had younger children that were in 5th grade or 4th grade, this is probably what I would give my child. If they lose it, I'm out $25. I'm not out $500 for an expensive cell phone. And they won't be looking at things online that maybe I don't want them to be seeing. Let's pick another example of pros and cons. Let's talk about disposable diapers. Now, if you have a younger sibling at home, you realize that, I'm talking like a kid under 5, that they go through a tremendous amount of diapers. And diapers, especially newborn diapers, those are expensive. They might go through 8 diapers a day. And so you could be spending $100 or more a month on diapers. And what do you do with them? You throw them away. Now, the alternative is cloth diapers. Now, cloth diapers can be reused over and over. Yes, when they're soiled, they have to be removed, and then the solids put into the toilet flushed, and then they have to be washed. The advantage of cloth diapers is you buy them one time. Now, you do have to wash them. That's a disadvantage. But here's the other advantage. In many areas of the world where they use cloth diapers because they can't afford disposable diapers, children are potty trained by the age of 3. Because those diapers don't pull the moisture away from your body. Instead, if you pee on yourself, you feel wet and yucky. And you realize that's not what you want to do. And so you get very good at realizing the sensation that you're about to pee, and you become potty trained. There are numerous children in America that cannot go to preschool because they're not potty trained yet, right? Because the diapers work too well. I heard one time that when your child is maybe 3 or 4, if you want to save some money, what you can do is, you know, in the summertime, pump your kids full of drink. Give them as much drink as they want to drink. Let them just wear a cloth diaper or run around naked if it's hot. Shut your blinds, you know, so people aren't looking in, and that kid will pee on themselves, and they will realize very quickly, within a day or two, that they need to pee, and they'll be potty trained. Now, you will probably have to then pay extra money to get your carpets cleaned and steam clean the couch or wherever they peed, but that cost will be a one-time cost of $100 versus spending hundreds of dollars each month for multiple more years. So with all technology, there's a benefit, pro and a con, right? If you want the newest cutting-edge phone, you pay a lot of money. If you want the newest piece of technology for your hobby, it costs a lot of money, and so on. So I'll give you another example. I do photography, so I have a couple of very nice cameras. I have a Nikon D5. That's the camera body alone costs about $5,000. When I bought it, it was $6,500. I have lenses that cost $12,000. Now, I could certainly shoot pictures with a cell phone and get okay pictures, but I want a lot higher quality picture, so I pay for that technology to have the best. In the real world, there's rarely a 50-50 consideration when thinking about a situation. So like if I have a decision to make, like should I do something or not, I generally write, what are the advantages? If I do it, here's what's going to happen. What are the disadvantages? And I look at that list. Sometimes just by writing it down, it will help me make that decision. Look, with technology, we can do stuff with gene therapy. We can alter the human genes, but we want to be very careful when we start to mess with humans and doing DNA sequencing and resequencing and then altering what Mother Nature did. There's lots and lots of examples of where that does not always come out very well for humankind. So I would always ask, you know, there's ethics involved in science. It's not just because we can do it, we're going to do it, right? There's a scientist in China 2 or 3 years ago that I believe cloned humans. Now that was a dark line in the sand that humans would never be cloned. And they did that technology. Now we learned a lot, but it was something that we thought should not be done. We can talk more about ethics of science another time. How does science advance? Well, oftentimes we think of we are standing on the shoulders of the people that came before us. So we can do more because we have the advantage of all the science they've learned, all the technology they developed. That doesn't mean we're smarter than them, not at all. It simply means we have the advantage of what they've left us. Sometimes, well, look, we got a little frog and a dog there, and I wonder what's going to happen. You know, it could be that that dog eats the frog. It could be that the dog hits the frog and knocks him away. It could be that the frog goes ribbit and the dog runs away frightened. Who knows? They're both a little curious about each other, but when you're little, you learn by curiosity. The best scientists, I would say, are 2-year-olds. If you are around a 2-year-old, every question they ask is, why? Why? What's that for? Can I do this? They're very, very curious. Then what happens is we send you to school, and at first you're all curious, raising hands, asking questions, and then after a while you stop asking those questions, because when you ask the question, the teacher did one of these. Yes, Jeff, what's your question? And you realize it just wasn't worth asking the question anymore. Now, I don't want that to be my class. I want you to be curious. I want you to be asking questions, no matter how far-fetched they are, right? That's how we learn. Sometimes those ideas that seem far-fetched are sometimes the best ideas. In science, we have to be good observers. There was a scientist named Fleming, and he was a biologist, and he would eat a healthy lunch, and one time he must have brought an orange to school, and he kind of left it and it rolled behind something, and he found it weeks later, and it was all white. It was disgusting, but he was curious, so he cut the orange open, and well, he looked at the white stuff growing all over it, and what he noticed is there was no bacteria on it. Now he knew, because he was a biologist, bacteria is everywhere, and then he concluded that that white substance must be killing the bacteria, and what he discovered was penicillin. Now I'll give you a personal story. My grandmother, I never knew, because she died in 1935, and what had happened is she had got an infection, a very bad infection in her leg, and she was hospitalized for about 6 months, and then she died from that infection. Now, several months after that is when penicillin was discovered, and people could take penicillin. Had she had penicillin, it would have cured the infection very quickly, and she would have survived. So sometimes we think of technology as really life-saving, can make a huge difference. Now, Fleming was a good observer. Scientists need to be a good observer. Doctors, medical doctors, are good observers, right? They ask you a bunch of questions. They're using the scientific method, trying to eliminate choices, trying to figure out what might be wrong with you. If they don't know, they send you to a specialist, which is even a better observer of the details of what you might have. Sometimes we're determined. Maybe we have something that happens in our life, and we don't want that to happen to somebody else, so we say, I'm going to figure this out, and I'm going to dedicate my life to solving this problem, and they're determined. And we'll talk about an individual who had determination like that, and sometimes you have to be very persistent. In the real world, scientists don't discover new things every day. They might spend their entire career working on something and only make a very small incremental increase in the knowledge. But sometimes those small increases are very, very important. Well, I want to talk about Charles Martin Hall. Now, Charles Martin Hall was a young man in college, and he was taking a class in probably geology. And his geology professor told him of this material, bauxite, that was in the earth. and that you could take bauxite and it contained the element aluminum. Now in 1850, aluminum sold for approximately $500 a pound. That's not $500 a pound in today's money. That was $500 a pound in 1850. Now, if you've ever been to Washington, D.C., and you've seen the Washington Monument, that obelisk-shaped thing, the very apex, the very top of that is a chunk of aluminum. It was much more valuable than gold in 1850 when they had finished the, well, it was actually later than 1850, but around the 1850s when they finished the Washington Monument. And so how did this work? Well, Charles Martin Hall, when he found out that the Earth's crust was made of bauxite, dropped out of college. He went in his garage, he worked for about 6 months, and he found a way to extract the straight, pure aluminum metal from the bauxite. And so he could take 4 to 6 pounds of this rock, pass an electric current through it, and he could extract out about 1 pound of pure aluminum. Well, when he made his method available, he ended up driving the price down from about $500 a pound to about 30 cents a pound. Now, in that process, he made himself very, very rich. It's rare that science is you come up with an idea, you go solve it, you make lots of money, and you do nothing else the rest of your life but enjoy that money. But that was the story of Charles Martin Hall. That's how he did that. Nowadays, we can still extract aluminum from the Earth's surface. It's still relatively common, but instead we recycle aluminum. It's a little bit more economical to do. All right, well, that is our lesson on the difference of pure science and applied science or technology. Remember, applied science is going to be something that makes your life better. Next, we will discuss the scientific method, but we'll do that on a different video. Thanks for listening.